Hello, good morning. So today we're going to continue our work with the rules of exponents. And again, we're kind of defining our own rules. These are not things to be memorized, but to really get how they work. Because once you're fundamentally getting it, you don't need to memorize anything. So here we're going to look at the context when exponents are involved with parentheses. Okay. So again, let's recall what do we mean by an exponent. An exponent means repeated multiplication. So in other words, 2 to the 5th power means 2 times 2 times 2 times 2 times 2. What's the difference between that and 2 times 5? Well, that's 2 plus 2 plus 2 plus 2 plus 2. That's why I say exponents and multiplication are faster than addition, right? So this is something that people get confused a lot. They say 2 to the 5th is the same as 5 times 2. It's not the case. This is actually 32, okay, whereas this would be 10. But repeated multiplication, it's this number, whatever this is, raised to itself or multiplied by itself 5 times. Okay, so let's do a different color here. So whatever is here, it gets multiplied by itself that many times. And I'm rewriting that because this should be the same understanding as if I had 2 in brackets, right? This would mean the same thing. It's 2 times 2 times 2 times 2 times 2. So what if I had a negative number in there? Negative 2 to the 5th. Well, that's negative 2 times itself. Whatever's inside the brackets, we say is what's being raised to the power. So here it's this whole negative 2, and so that's why we keep the whole thing. So this ends up being negative 32, which is different. So if I throw a variable in there, how about negative 2x to the 5th power? What does this really mean? Again, whatever's included in the brackets, that's what's being brought to this exponent or this party of repeated multiplication. So we get negative 2x times itself. And so what does this end up being? Well, if we use the property that we learned last time, I can rewrite all of this as, right, negative 2 times itself 5 times. And then x times itself 5 times, right, using the commutative property. And then I know this would be equal to negative 32x to the 5th. And if I scale it up a little bit and I said, what about, negative 3x squared to the 4th power? What is this? Well, this is whatever's inside the brackets. 1, 2, 3, 4 times negative 3x squared, negative 3x squared, 4 times. And then again using that property of commutative property of multiplication. So I have 4 factors of negative 3, and I have 4 factors of x squared. And then we can just do the work of calculating what this should be. So negative 3 times itself 4 times is positive 81. And how many x's do I have here? Well, I have 2, 4, 6, 8, x to the 8th. So, what are we noticing? That when we have these brackets, this is all it means, right? So I want you to kind of like write this down as a general idea that this is repeating whatever's in the brackets by itself n times. Now there are all sorts of shortcuts that you can memorize about this, but this is what will help you build your own shortcut. And that's exactly what I want you to take away from this unit. Okay, so let's do a few examples here together because it's really through that we get the most bang for our buck, I think. So let's say we've got negative 4 q squared s cubed t to the fourth all to the third power. And we'll say, simplify this expression. So maybe we've, taken some expression and plugged it into something that was being cubed. Doesn't matter, we're practicing the skill of doing this for the future. So what does this mean? This means whatever we have on the inside 3 times, right? 1, 2, 3. So we get negative 4 q squared s cubed t to the fourth. Getting a little tiny in there. It's okay. Q squared s cubed t to the fourth. Negative 4 q squared s cubed t to the fourth. And now I can rewrite everything with the real number coefficients out front. All my q terms. All my s terms, and then all my t terms. I should have 3 of each, right? Because of 1, 2, 3 coming from that. And now we can simplify. So negative 4 times itself 3 times is what? Negative 64. How many q's do I have? 1, 2, 3, 4, 5, 6. How many s's do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. And how many t's do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. T to the 12th. So that has been simplified. Again, just using what we know about exponents, which means repeated multiplication. So let's do 1 or 2 more here. Let's say I have a fraction involved. Let's say I've got, b to the 5th over 10 all to the 4th power. How would we rewrite this? Well, it's whatever we have times itself. How many times? 4 times. 1, 2, 3, 4. b to the 5th over 10. And so there's a few ways you could think about this. One would be to just multiply the tops and the bottoms, because that's what we do with fractions. That's what I'm going to do here, but I'll show you another way to think about it as well. Whatever works for you, whatever makes the most sense. So we could rewrite this, since these are all fractions, to be, well, the tops, b to the 5th, times the bottoms, 10 times 10 times 10 times 10. And then we could just simplify like this, right? So b to the 5th, how many do we have in the top? 5, 10, 15, 20 factors of b. And then 10 times 10 times 10 times 10 should be 4 zeros, so 10,000. And that's as good as we get. Okay, so how many factors do we have? Putting like things together and then simplifying as best we can. The other way that you could have done this that was kind of in line with the other problems we've been doing is pulling off the real numbers to the left and saying this is really like 1/10 times itself 4 times, then times b to the 5th over 1, and that would take you to the same place. So either or. And let's just ratchet it up for one more, maybe harder level problems. Let's say I've got 6xy times 2x squared y to the 3rd z all over 4x cubed y squared. And this is all to the 4th power. This is kind of putting together the last section in this section all in one. So you might even consider doing some practice problems before watching me do this. But let's jump in. So how can we do this? So here's the thing about this, and I don't want to lie to you and say, this is the way you always got to do it. That's not the case. We're dealing with multiplication, which is a commutative property. What does commutative mean? Commutative means 2 times 3 is the same as 3 times 2, right? It means the order doesn't matter. So it'll matter when it comes to the division, but we can do a lot in different ways. So you might not see it the way I see it. You might tackle it a different way. As long as no rules are broken and the logic is followed, it's fine. But I'll just say that you can view this from many different perspectives. You could start by expanding this out to be 4 of these things. But really what I would like to do is, as best you can, simplify the inside first. And the reason for that is because if there's anything that can simplify in here, then I won't need to carry that ugliness forward into 4 big factors, right? So simplify the inside first. That's my pro tip. Okay. So let's start with simplifying. If we start on simplifying the inside, then we'll start simplifying the top and then the bottom. Those are the two components of the inside component, right? So we'll start with the top and then the bottom. So simplify the top. 6xy 2x squared y cubed z all over. We'll leave everything else by itself for now. What is that? Y squared. So up top, we can do what we normally do. Bring the coefficients to the left side. 2 times 6. Then all my x terms. X squared, y cubed, and then we have a z just hanging out in there. It's all over 4x cubed y squared. This is all being raised to the fourth. Notice how nothing there changed. And now I can simplify. The 2 times 6 is 12. How many x's do I have? How many y's do I have? How many z's do I have? Nothing else changed. From here, again, we're as good as we can get in the top. There's no brackets. There's no terms that need to be multiplied together. So now we can simplify the top and bottom together by saying, okay, well, I've got a x cubed and x cubed up top and bottom, so these factors will cancel. 12 can be written as 4 times 3. So a factor of 4 will cancel with this factor of 4 down here, leaving me with a 3 up top. I'll have 2 y's cancel with 2 of these y's up here, leaving me with 2 y's. And then the z will be left as well. So what do we get? We get 3 times, everything canceled in the bottom, so we should be left with 1. 3 times, there's no x's, there's 2 y's, y, z, all to the fourth. And just to neaten that up a little bit, 3y squared z all to the fourth. And now we can use what we know about this last piece. Isn't this much nicer to do than to multiply 4 of these things by itself, right? So we get then 3y squared z, 3y squared z, so we get 3 times 3 times 3 times 3, y squared, y squared, y squared, y squared, z, 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 z. All right, so how many of each do I have? Well, this becomes 81. I have 8 factors of y, and I have 4 factors of z. And so there we are. So you might see the end run you can make, right, or the shortcut going from here to here. What do you think that is? Right? If I know I've got this many factors of each of these things, what's the pattern here? If you're not seeing it, that's fine. This will always work, but eventually you'll start to notice what happens. And you can speed up this process. But don't rush it, and don't try to use a shortcut if you don't know what it means. Again, this is the reason why we're in this class, is to undo all the damage that's been done by those things. Let's just make sense of it. Let's just have it always make sense. So, that's kind of like an easy, medium, hard of this. I just wanted to again clarify the difference, right, in remembering that 3 to the 5th, like negative 3 to the 5th versus negative 3 to the 5th. So the difference between when brackets are used with an exponent and when they're not. Here, this 3 is really only tied to this, or this 5 is really only tied to this 3. And here, this 5th power is tied to the whole thing. So this becomes negative 3 times itself 5 times, because that's what the exponent is telling us. Whereas this is saying I've got 3 times itself 5 times, and this negative is just here. It means the opposite of whatever this thing is. So this might seem like a subtle notational thing, but it is a big difference. These two end up being the same answer, but it's not always the case. If this is an even power, it ends up mattering a great deal. Okay. So just to be aware of the importance of brackets with exponents. It changes the meaning when the exponent is outside of a bracket and when it's not. Okay, so you got to ask yourself, who's coming to this party of the 5th power? And if we want to look at, a weird one maybe involving brackets, just to kind of highlight this point. What if I had x squared to the 3rd all to the 4th power? Try it on your own. Hit pause right now and try to see and make sense of this. Just get your hands dirty with it. Maybe you don't come up with a solution. That's okay. But kind of test yourself on what you know to be true. Break this down into what the exponents mean. How many x's should you have at the end of this? Okay, so what does this mean? So I have 3 sets of this is what's really on the interior here. So x squared times x squared times x squared. I'm going to simplify this before I move on. I don't have to, but it's going to make life a lot easier, right? So how many x's do I really have? I really have x to the 6th, all to the 4th power. And so what does that really mean? It means I have x to the 6th, x to the 6th, x to the 6th, x to the 6th, which is how many x's all day? It's 1, 2, 3, 4, x to the 24. Okay. So again, ask yourself, how could we get from here to here? What's the relationship between this expression and the simplified answer? Okay. So this is how we deal with brackets and exponents. And even when they include fractions, simplify the inside as best you can before moving on. Now this one they all canceled, so I actually want to do one more where they don't cancel, just because that can be a point of confusion. X squared, let's say simplify. We're getting sick of x, let's switch it up. A cubed b to the 5th over c squared d cubed squared times c over a. Let's do it like that. Okay, some good fraction work. So again, all this is happening is multiplication, exponents, and division. So what are we going to do here first? Inside out, right? Order of operations. Brackets first, and then whatever we can do to simplify. So in here, nothing to really simplify. Right? Can't do much. A doesn't cancel with C. B doesn't cancel with D. So really, the exponents come up next of raising this bracketed expression and squaring it. So what does this mean? It means 2a cubed b to the 5th over c squared d cubed times itself. 2a cubed b to the 5th c squared d cubed, all times c over a. And we can just rewrite what's happening on the left here. 2 times 2 times a cubed times a cubed times b to the 5th times b to the 5th, right? Commutative property of multiplication. Then same on the bottom, c squared d cubed, all times this c over a. And so do we get anything nice to cancel? Well, I have one factor of c up here that will cancel with one c down here. One factor of a that will cancel with one factor of a up here. Right, because this is really a times a times a. And so this is all taken care of. So now we can just rewrite it. 2 times 2 is 4. A squared times a to the 3rd is a to the 5th. How many b's do I have? How many c's do I have? And how many d's do I have? Okay. So again, if that went really quickly, pause, rewind, go back through and see why we end up with the number of factors that we do here. But this is going to rely on that fraction multiplication, which maybe it's been a bit. If I have 1/2 times 3/4, this becomes, right, it goes top to top, bottom to bottom. And then we can simplify common factors. Okay, so that's all the examples I wanted to go through for this section. Have fun. Again, think of this as like a puzzle and derive your own rules or shortcuts from this because they make sense. And make sure you post any questions that you have in the class discussion, and we'll see you there.